Hello, good evening everyone. Can everyone hear me? Rafti, Manandit, Shomita, can you people hear me?
Yes, sir.
Okay. So Anandit, you are joining after so long.
Yes, sir. I had two exams in the between, block exam.
Okay. Now that your exams are over, did you go through all the notes,
Yes, sir. Yes,
videos?
sir. Yes, sir.
Okay.
You sent two videos. I went over it. I also sent you my homework.
Okay. When did you send me your homework? Today?
Yes, sir. Today in the in I guess at like in the morning, like before after 12 o'clock.
Okay, let me see. Oh, I forgot to check. Anyways, so let us discuss the homework questions. Can you people see my screen? Okay, so these were the homework questions I had given. Okay, I'm going to write down the answers. You people match. Okay, so first one. Okay, everyone. First one would be okay, wait, I'm writing down the answers. First one is 12 factorial divided by 12 factorial divided by 3 factorial whole square into 2 factorial whole cube. Okay. Next one. Next one, the answer is okay, it was numerical answer. Okay. Wait, just give me 1 minute. Okay, wait. Achha, this one, the answer is 240. Okay. Then 240, then 255. Anyone having any doubt in 1, 3, write 2 also? Give me 1 minute. Okay. Find the number of ways in which 5 ways. Okay, wait, I'm writing these answers. Wait. Find the number of ways in which 5 ways and 6 p's can be arranged in a row. Yes. The next one is answer is quite big. Okay, I mean number two. Number two's answer, I'm writing it over here. Okay. Number two's answer, I'm writing it over here. It will be 8 factorial divided by 1 factorial whole to the power 4 into 4 factorial multiplied by 1 by 4 factorial plus 8 factorial divided by 2 factorial into 3 factorial multiplied by 1 by 3 factorial plus 8 factorial divided by 2 factorial whole cube into 1 by 2 factorial into 1 by 3 factorial. The whole thing is multiplied by 5 factorial. Tell me, anyone having any doubt? 1, 2, 3. Tell me. Raktim, Anandit, Shomita, Devang. Tell me. Anjali.
No, sir.
Okay. On any you have any doubt till now?
No, sir.
Number 4, 5 A's and 6 B's. Number 4, the answer is 10. Okay. Number 5, the answer is 1080. 1080 and 330. Anyone having any doubt, tell me. Ratim, Anandit, Devang, Somita, tell me. See, this came in J mains. Number 6. The answer is 16,800. Anyone having any doubt, tell me. Okay, next. Number 7, 4806. Okay. Number 8, find the number of words using all the letters of the word examination. Wait a minute. Yes. Using all the letters of the word examination. Okay, over here the answer is 11 factorial divided by 2 factorial whole cube. Okay, 11 factorial divided by 2 factorial whole cube minus 3 into 10 factorial divided by 2 factorial whole square plus 3 into 9 factorial by 2 factorial. Okay, minus 8 factorial using inclusion exclusion. Next, number 9. Number 9, 4 faces of a tetrahedron. 430. 9. Okay. 9, it is given that 4 faces of a tetrahedral dice are marked 2, 3, 4, 5. Okay. The lowest face being considered as the outcome. Okay. In how many ways? A total of 30 can occur in 7 throws. Okay. A total of 30 can occur in 7 throws. So let us start. Much a total of 30. You know what is a tetrahedral? Tell me. This is number 9. Okay. Okay. So over here, there are 7 throws and the sum should be equal to 30. 7 throws and sum should be equal to 30. Okay. So I'll take cases. Okay, I'll make a table. In how many ways can the sum be 7? Can the sum be 30 in 7 throws? Okay, so case 1. Okay, case 1. There are how many? They are marked with 2, 3, 4, 5. Okay. So either you can get the lowest phase being considered as the outcome. Okay. Acha, I understood. So either you can get 5, 5, 5, then 5, 4, 5 is 20. Another 5 you can get, then 2 and 3. In how many ways can you get 5, 5, 2 and 3? Tell me. Pratim. In 7 throws you have to get
7 factorial by 5 factorial.
7 factorial by 5 factorial. That will give us how much? 42. Next. 4 5s. Now let us see if it is possible to take 4 5s. I have started with the maximum one. 4 5s, 20 is done. Now in 3 throws you need to get 20. It can be 4 4 2. Tell me.
Sir,
Yes, tell me.
sir, it says the lowest phase is considered as the outcome. When will 5 ever be the lowest phase?
No, lowest face means what? Okay, the face which is below. Okay, that we have to consider it.
Okay. So I was thinking the least value.
At first, I also thought that how can be the lowest phase? We are throwing it. Okay. So no, but actually lowest phase, the phase which is below, okay, that is considered as the outcome. Okay. Or actually, this doesn't have any meaning related to counting. Okay. This statement doesn't have any meaning related to counting. Okay. The lowest phase, or you can also say that the phase which comes on the top is considered as the outcome. Are you getting?
Yes.
Okay. 5, 5, 5, 5, 4, 4, 2. Okay, this can be done in how many ways?
So 7 factorial by 4 factorial by 2 factorial.
4 factorial into 2 factorial.
Yes,
This will give us how much? 105, right? 7 factorial is equal to
yes,
5040, and 4 factorial is equal to 24. I think 105 only. Next, again 4 5s. Okay, 1 4 and 2 3s. This can be done in same way, 105. Okay, now considering 3 5s. 3 5s. Okay, slowly I'm decreasing the number of 5. 3 5s, 15. Now some of the numbers should be equal to 15. That can be done in 3 4s and 1 3. So this is nothing but 7 factorial divided by 3 factorial whole square. Let us calculate. 7 factorial is 5040. 5040 divided by 36. Let's calculate how much? 6 times 6, 6, 48, 24, 84, 840. 140. Tell me. Okay. Then 3 5s, 3 4s. Achha, this we have already considered. Okay, considering 2 4s, is it possible? No, 2 plus 5. Then it would be same case as this one.
yes, sir.
2 5s, no. 3 3, 1 4 and 3, so I have already considered. I think 3 5s and 3 4s, this will be the only case. Achha, it can be 2 5s and 5 4s. Right.
Yes, sir.
Tell me, Shomita, Devang, are you getting? Amini, Anandit, is it clear? Tell me.
Yes, sir.
Okay. This will come as how much? 7 factorial divided by,
5 factorial into 2 factorial.
okay, that is nothing but 42. No, wait, 7 6 7 6 42 by 221. When you add, how much it is coming? 210, 350, 350 plus 63 is 413. Is it clear? Everything is it clear?
Yes,
Okay. Next, number 10. This is also a
sir.
lengthy answer.
Sir, I have tried, sir. Why there was written 7 hours?
Why there was written
7 hours in the last. Yes, 7 rows.
7th rows, 7th rows.
Yes, only.
Yeah, how many 6-lettered words? Okay, can be arranged. So from the letters of the word integration. Okay. This one, I'm writing down the answer. Anyone having any doubt, tell me. 1C1 into 1C1 into 3C1. No, 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 no. Not this one. 1C1. Okay. 1C1 into 3C1 into 2C1 into 3C1 into 6 factorial divided by 2 factorial whole square. Okay. Plus 1C1 into 3C1 into 4C3 into 6 factorial divided by 2 factorial plus 4c1 into 2c1 into 3c1 into 6 factorial divided by 2 factorial. Okay. Is it clear? Anyone having any doubt? Tell me. Okay. Number 11. Samita, you have any doubt? Tell me.
Sir, in number 12.
Number 12. Okay. Others, Andrini, you have any doubt? Tell me. Okay, number 11, I'm writing it over here.
No, sir.
Number 11. It will be 1c1. Devang, you have any doubt? Into 3c1 into 4 factorial divided by 2 factorial minus 3 factorial divided by 2 factorial plus 1c1 into 4c3 into 4 factorial minus 3 factorial. Okay. Plus 1c1 into 3c2 into 4 factorial divided by 2 factorial. Okay, plus 4c4 into 4 factorial. Okay, is it clear to everyone? Tell me. Next. Number 12 I'm solving. Number 12 I'm telling you the answer. Number 12, the answer is how much? 1080. Okay. The answer is 1080. So I'm solving number 12. Swamita, pay attention. In a hotel room, 4 rooms are available. 6 persons are to be accommodated in these 4 rooms in such a way that each of the rooms contains at least 1 person and at most 2 persons. Find the number of possible ways in which it can be done. At least 1 person and at most 2 persons. Okay. 4 rooms are available. Okay, let us start. 6 persons are to be accommodated in these 4 rooms in such a way that each of these rooms contains at least 1 person and maximum of 2 persons. Okay. So in the beginning, okay, in the beginning, let me solve. There are 4 rooms. Okay. At least 1 person and at most 2 persons. So first of all, P1, P2, P3, P4, P5, P6. There are 6 persons. I need to distribute in such a way such that minimum of 1 person is there and maximum of 2 persons is there. Okay. So wait a minute. I think we can do it by inclusion exclusion. Let me see. What is written? At least 1 and at most 2. At least 1, at most 2. What is the total number of ways in which 6 persons can be accommodated? Total will be how much? Each person can choose 4 rooms, right? So it is 4 to the power 6. Any of the 4 rooms. Each person has 4 choices. So 4 to the power 6. But that is huge. Achha, anyways, next. at least one person and at most two person. What is the number of ways? No, no, not like this, not like this. Okay. Like this. What you do is, first of all, you select 4 persons, okay? Number of ways to select any 4 persons will be? Select 4 persons will be? Tell me. Samita, 4 persons will be accommodated into 4 rooms in how many ways? I mean, tell me. First of all, you select any of the 4 persons. Tell me. In how many ways can you select any of the 4 persons? Tell me.
Sir, 64.
64. Okay. And in how many ways we can arrange them? Into 4 factorial, right?
4 factorial.
Number of ways to arrange them will be equal to 4 factorial. Okay. So how much are we getting? Therefore, total is equal to 15 into 24, which is equal to 360. Right. Okay. In every case, 2 persons will remain. Wait, forget about this. Okay, I'll make groups. Okay. 6 persons can be made 4 groups. Okay. In how many ways? Tell me. Okay, I need 2 to 1 groups, right? Number of ways to form groups. This way is better. Okay, wait. This way is better. I've got it. Okay, number of ways to form groups. Number of ways to form groups will be equal to 6 factorial divided by 2 factorial whole square into 1 factorial whole square multiplied by 1 by 2 factorial whole square. Right, tell me, Samita.
Yes, sir.
This is how much? This will give us how much? Now, let us say you have got 4 groups, A, B, C, and D. 4 groups can be arranged in 4 rooms in how many ways? Number of ways will be equal to 4 factorial. So it will be 6 factorial divided by 2 factorial whole square multiplied by 1 by 2 factorial whole square multiplied by 4 factorial. Is it clear? Tell me, Samita.
Yes, sir.
2 square is 4. So this will go by 3 factorial. I think answer should come. Let's see. And over here, 2 factorial, 3 will get cancelled. And over here we'll get 3. Then over here 720, 360. Yes, 1080, it is fine. This is best. Okay, you have to form groups of 2, 2, 1, 1 each. Okay, because if it is said that at least one people will be there and at most 2 people will be there, okay, then this is the only way you can form groups of 4. Are you getting? Tell me. This is the only way to form groups. Is it clear to others? Tell me. Amandit, Devang, is it clear? Ratin, Nini, is it clear?
Yes, sir.
Okay. What I was. See, this came in advance. It was easy only. Okay. You have to just form groups. Okay, next. So last day we were discussing circular permutations. Right, everyone? Okay, I have discussed circular permutations. We did it didn't do any problem. Okay. So there are a few more theorems I need to discuss. Okay. So everyone, there is a theorem. Number of ways to permute n things. Number of ways to permute n things. Take n. R at a time.
Sir,
Oh, this I've already done. Okay, another theorem. Okay. If anti-clockwise and clockwise arrangements are considered, and clockwise, if anti-clockwise and clockwise arrangements are considered, if anti-clockwise and clockwise arrangements are considered to be same, okay, then the total number of circular permutations of n things will be equal to n minus 1 whole factorial divided by 2. Okay, let us see the proof. Okay, but first of all, I'll give you an example. For example, if we arrange, okay, in this example only you will understand why it is divided by 2. If we arrange garland of flowers or a necklace of beads, okay, okay. So let us say that this is the arrangement of a necklace or a flower or a garland. A, B, C, D, E. Okay. So try to understand, everyone. Over here, let us say you are holding the garland from this side. Okay. You are holding the garland from this side. Okay. You are looking at the arrangement in the clockwise direction. Right. Tell me, everyone. You are holding the garland from here. You are looking at the arrangement in the clockwise direction. Yes or no? Tell me. Hello. Are you people getting? Samita, are you getting? You are able to understand? Okay. But the person behind you, okay, the person behind the garland, okay, he will look, according to him, the flowers are arranged in the anti-clockwise direction, right? How the person on the other side of the garland will look at the arrangement. On the other side of the garland, he will look at the arrangement like this. Are you getting? Tell me, everyone. So see, A, B, C, D, E in anti-clockwise direction. A, B, C, D, E in anti-clockwise direction. And this one is A, B, C, D, E in clockwise direction. Sorry. This one is clockwise, this one is anti-clockwise. Tell me. Are you getting, Devang? Both the arrangements are same? Yes or no?
Yes, sir.
Okay, that is why we have to divide it by 2. Note the distribution between clockwise and anti-clockwise arrangements. is ignored is ignored when a number of people is sitting when a number of people is sitting in a round table is sitting in a round table. Okay. Why it is ignored? Because let us say that the person is sitting, the people are sitting around the round table like this, A, B, C, D, E. Okay. Over here, the anti-clockwise arrangement will be from the floor. Right, try to understand. But who will look at the arrangement from the floor? Are you getting? Is it clear to everyone? So that is why the anti-clockwise arrangement, I mean, they are not considered same. Okay, they are considered different. Next. Okay, so everyone, let us do some problems. Okay, Tomita, till now you have any doubts? Tell me.
No, sir.
Okay. Wait. Anjali, is it clear? Yatin,
Yes, sir.
Yes, sir.
Anandit, is it clear?
Yes, sir.
So these are the two problems for today. Solve. Question number 1 and 2. Once you have done, give me your answers. So I'm starting with the first one. Okay, everyone. We need to find out the number of ways in which 7 Chinese and 7 Indians can be seated on a round table so that no two Indians are together. No two Indians are together. That means between every two Chinese, there should be an Indian, right? And between every two Indians, okay, between every two, yes, Raktim, tell me.
Sir, one sentence only.
Okay, sir.
Sir, did you receive my answer? It's showing a single tick.
Wait. It will be received. Give some time. Till then, you solve number two. Or Nini, check your answer again. Why did you divide it by 2? Cannot understand. Samita, right answer. Okay, Raktim, check your answer again. Okay, Raktim, I'm solving. Pay attention. Raktim, Devang, and Andit, pay attention. So at first, what you do is, yes, Anandit, your answer is correct. Okay, Raktim, I'm solving. So find the number of ways when 7 Chinese and 7 Indians can be seated on a round table so that no 2 Indians are together. What you do is, first of all, you arrange Chinese. Are you getting Devang? Arrangement of Chinese can be done in how many ways? Tell me. Devang?
So in circular manner,
Of course. In a round table we are talking. 6
6
factorial,
factorial by 2,
and they will give how many gaps? What is the number of gaps they can give?
7, 8 gaps.
Wait a minute. 7 gaps. Why 8 gaps?
It is 7 Chinese though.
But it is a round table, no?
Oh,
See, it's a round
yes,
table.
yes, sir.
C1, C2. Okay, up to C7. It's a round table. So number of ways. And 7 Indians can arrange themselves in 7 gaps in how many ways? 7 factorial. Is it clear? Tell me.
Yes, sir.
Devang, Raktim, is it clear?
Yes, sir.
Okay, solve number 2 quickly. You need to find out the number of ways in which 5 boys
And
have sent it. Give me one more. Oh, but I've got the answer in the form of factorials. Okay, Samita, there's a slight mistake. So, Nini, check your answer again. Okay, so let us start. We need to find out the number of ways in which 5 boys and 5 girls can alternately sit in a circle if a particular boy and a particular girl are always, if a particular boy and a particular girl are never adjacent to each other. Okay. Ratim, check your answer again. Okay. So what is the number of ways? What I'm going to do is total minus always together. Okay. Total minus V1, G1 always together. Are you getting? Devank, Samita?
Yes, sir.
Yes, sir.
Okay. What is the total number of ways to arrange them alternately? Tell me. Devank, tell me. Just now we have done a sum like this. What is the total number of ways to arrange them alternately?
Sir, 5 in, wait, 5 into 4 factorial ways.
4 factorial into 5 factorial, right? There are 5 boys and 5 girls.
Oh, yes, yes.
Minus, okay, B1, G1 should be together and other people will arrange alternately. So what is the number of ways in which other people can arrange alternately? Tell me. What is the number of ways other people can arrange them alternately? Tell me.
6 factorial ways.
What? Alternately. Other people except B1, G1.
Sir, 4 factorial into 3 factorial.
3 factorial into 4 factorial. Right, tell me. Now my task is to place B1, G1. Right. My task is to place B1, G1. In the gaps, right? In these gaps, we need to place B1, G1. So try to understand. B1, G1 can occupy this gap, 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 can occupy this gap. Total, how many gaps are there? Tell me. Total
6.
6 gaps are there. Okay, so they will first of all select the number of gaps. Achha, there are 2 more people, I guess. E5 is there, G5 is also there. So total, how many gaps are there? Number of gaps will be equal to, what is the number of gaps? 8. Number of ways to select the gaps. To select gaps, how many ways? Number of ways to select the gaps will be equal to 8C1. Right, tell me. Next, after selecting the gap, in how many ways they can arrange themselves in that gap? Tell me.
3 factorial.
2 factorial. So you are telling me that over here we can place B1 G1 also and G1 B1 also. Tell me.
No, sir.
No. Why no?
Because there is said alternately, so one way.
Alternately. Exactly. Only one way. Number of ways to place them in gap. Are you getting Devang, Anandit,
Yes,
Omnini?
sir.
Will be equal to only one way. So therefore the required number of ways will be equal to 4 factorial into 5 factorial minus 3 factorial into 4 factorial into 6C1. Done. Okay. Next. Sorry, not 6C1, 8C1. Is it clear? Omnini, is it clear? Tell me.
So I sent it. I did it differently, but it's the same value.
Same value.
Yes, sir.
So what?
So second time actually I took B1 G1 its position as constant and I arranged the rest around it.
Oh, okay.
Yeah. But I'm getting this only.
Okay. Okay, let us do 2 more problems. Another set of problems. quickly. Number 3 is easy. I should get the answer within seconds. Out of 10 flowers of different colors, how many different garlands can be made if each garland consists of 6 flowers? It's very easy. Number 3 can be done quickly. Amita, you are forgetting one thing. It is a garland of flowers.
Yes, sir. Yes, sir.
Understood where you are making the mistake.
Yes, sir.
And same thing on Nini also. It's a garland of flowers. Yes. On Nini now it is correct. Laktim, your answer is correct. Amandit, Devang, Shomita, I'm waiting.
Sir, please wait. I'm almost done.
Oh, you have calculated the final answer. Laktim. No, Amandit.
So will I give it in factorial?
Would be better.
Okay, sir.
Sir, we have to give it in factorial.
Hmm.
Okay, sir.
Okay, Amandit, your answer is correct only. Okay, I've calculated. Yes. Shomita, your answer is correct.
So can I leave it in factorial or do I need to break up?
No. It depends upon the options. Okay, but currently you can leave it in factorial.
Okay, sir.
So can you scroll down? I can't see the last line of 4.
Hmm. Okay, Devang, have you written divided by 2?
Yes, sir.
Okay, it is correct. So since everyone has solved number 3, I'm not solving. Okay, you people solve 4. Okay, 4 I'm solving, everyone.
So I'm saying
Okay, same. Okay, Anjali, check your answer again. Okay, I'm solving it out. There are 16 knights on a round table. They are required to rescue the queen. Every consecutive knight is hostile to each other. Means if two knights are sitting side by side, they are hostile to each other. Are you getting? Means there is a. You people know the meaning of hostile, right? Okay. Means they cannot work together. Something like that. Okay, Raktim, check your answer again. Okay. Next. So what you do is, over here, we have to choose the knights from the gaps, right? So write it down. This is the gap method for circles. Okay, everyone. The gap method for circular arrangement. Okay? Gap method for circular arrangement. So what you do is, you first of all remove 7 knights. Remove 7 knights. Okay, remove 7 knights. Okay, how many knights are remaining? 9 knights are remaining. What is the number of gaps by those 9 knights? What is the number of gaps?
no.
9 knights? Acha, wait. Wait, I didn't tell you something. Okay. Remove 7 knights. Okay, let us consider a linear arrangement. Okay. Means 16 knights are arranged in a line K1, K2 up to K16. Okay. Now, instead of this circular arrangement, if it was, instead of this linear arrangement, if it was a circular arrangement, can you people understand that the first gap and the last gap are same? Yes or no? Tell me, Raktim, Anandit, Shomita, Devank, are you people getting? If
Yes,
it
sir.
was a circular arrangement, the first gap and the last gap will be same? Yes or no?
Yes, sir.
Okay. So first of all, let us consider a linear arrangement. You tell me how many gaps are there? Number of gaps in a linear arrangement? Tell me. Anjali, Shomita, Devank, Anandit, tell me how many gaps are there? Tell me.
So in total, between the 16 knights.
In a linear, no. Number of gaps after removing 7 knights.
10.
10. After removing 7 knights. Okay. This will give us how much? So number of ways will be equal to how much? 10C 7. Right, tell me everyone. Number of ways will be equal to 10C 7. Now you people tell me, if it was a circle, the first and the last gap is same. Right, tell me. If it is a circle, the first and the last gap is same. For a circular arrangement, first and last gap is same. Right, tell me. So what I'm going to do is I'll subtract those cases when I'm selecting the first and the last gap. Right. So what is the number of ways we can select first and last gap? Tell me. What is the number of ways in which we can select first and last gap? Tell me. What you do is you first of all select the first and the last gap. That can be done in 2C2 ways. That is one way. Next. Out of the remaining number of gaps, how many gaps you need to choose? How many gaps are remaining? Tell me. How many gaps are remaining?
Sir, 8.
8 gaps are remaining. Okay. Out of the 8 gaps, you need to select how many gaps, Devang? 5 gaps? Because I've already selected 2 gaps. Right, it is 2C2. I've already selected 2 gaps. So what is the number of ways? Number of required ways will be equal to 10C7 minus 2C2 into 8C5. Tell me, is it clear to everyone? Ratim, Anandit, Devang, tell me, is it clear?
Yes, sir.
Emily?
Yes, sir.
Okay.
Yes, sir.
So I'm going to generalize this gap method for circular arrangement. Okay, I'm going to generalize this. Okay, generalization. Okay. Total ways to select. Total ways to select R out of n people. R out of n people in a round table. In a round table. So that no two of them are consecutive. So that no two of them are consecutive. Are consecutive. Okay. First of all, let us find it out, then I'll write it. Okay. So tell me, if it is a linear arrangement, okay, after removing R people, how many people are remaining? Number of gaps remaining. If it is a linear arrangement, tell me.
N minus R plus 1.
N minus R plus 1. Okay. And okay, number of gaps remaining is n minus r plus 1. Okay, so number of ways to select r gaps will be n minus r plus 1 cr. Next, now number of ways to select the first and the last gap that we have to subtract. To select first and last gap, tell me, in how many ways can you select the first and the last gap? Tell me. In how many ways can you select the first and the last gap? Amini, Devang, Raktim, Anandit, tell me. In how many ways can we select the first and the last gap? 2C2 into, tell me, everyone, 2C2 into how much? How many gaps are remaining? After selecting the first and the last gap, how many gaps are remaining? Previously, there were n minus r plus 1 gap. Now you have already selected 2 gaps out of the 2 gaps.
So n minus r minus 1 c r minus 2.
N minus r minus 1 c r minus 2. Right, tell me. Samita, is it going above your head? Tell me. You're able
No,
to
sir.
understand, right?
Yes, sir.
Devang, you're able to understand?
Yes, sir.
It's not going above your head, right?
No, sir.
Okay. And Anandit, is it clear? Tell me.
Yes, sir.
CR minus 2. Okay. So minus n minus r minus 1 CR minus 2. Okay, this will be your final answer. Okay. So let us do some problems. Okay, question number 6. Question number 5 and 6 I will post. Okay, this is number 5. Solve quickly. 5 is very easy. Should I start number 5? Okay, see everyone. We need to find out the number of ways in which 9 people can be seated in a round table so that all shall not have the same neighbors in any two arrangements. Okay. Yes, Soumita, right answer. All of them should not have the same neighbors in any two of the arrangements. Okay. So try to understand. I'm taking with only 3 people. Okay. 5 people. Okay. So let us say in one of the arrangement, A's neighbor will be B and C. Yes or no? In one of the arrangement, A's neighbor would be B and C. Yes or no? Tell me. Onmini, Raktim, Anandit, Devang. Tell me. Okay.
Yes, sir.
Okay. Next. In another arrangement, A's neighbor can be again B and C, but in this way. Right. So basically, anti-clockwise arrangement and clockwise arrangement should be considered same only. Right. We have to find out the number of ways to arrange so that they should not have the same number. Means both the arrangements should be considered same. Right. This implies anti-clockwise arrangements. Right. Are you people getting why should we consider anti-clockwise and clockwise arrangements as same? And clockwise arrangements,
Once more.
yes. So Devang, this is one of the arrangement in which A has neighbors B and C.
Yes, sir.
This is another arrangement in which A has neighbors B and C. Right.
Yes, sir.
So try to understand. Both the arrangements should be considered same. Yes or no? That is what the question demands. The question asks us to find out the number of ways to arrange so that all shall not have the same neighbors. Means A should not have the same neighbors B and C in another arrangement. Understood?
Yes,
So
sir.
that is why we need to count the clockwise arrangement and anti-clockwise arrangement same only. Right?
Yes, sir.
Should be considered same. Thus, number of ways to arrange will be 8 factorial by 2. Is it clear? Onmini, Raktim, Anandit, tell me.
Yes.
Okay, quickly solve 6. N people are sitting in a circle. Find the number of ways in which 3 people can be selected so that no 2 of them are consecutive. Very easy. Just now we have done it. A similar type of problem. So Samta, can you give the answer in terms of expression?
Yes,
Would be
sir.
easier. Yes, Ratin, your answer is correct. Okay, I'm solving everyone. N people are sitting in a circle. Find the number of ways in which 3 people can be selected if no two of them are consecutive. Let us start. Three people can be selected so that no two of them are consecutive. Number 6. N people are sitting in a circle. So first of all, tell me. First of all, you have to remove those 3 people. What is the number of gaps in linear arrangement? In linear. After removing 3 people, tell me. What is the number of gaps? Tell me, everyone. Hello.
So we can use the formula directly.
We can directly use the formula, but still, in the exam, there are high chances that you can forget the formula, right?
Yes.
So tell me, how many gaps are remaining? How many gaps will be there after removing 3 people?
So n minus 2.
N minus 2? Right, tell me, Anandit, are you getting? Number of gaps in linear?
Yes, sir.
Okay. So therefore, number of ways. And we need to select how many gaps? 3 gaps? N minus 2, C3. But from here, we need to subtract those cases when you're selecting the first and the last gap. So number of ways to select the first and the last gap will be 2C2 into N minus 4C1. Right. Tell me, Shomita, Onini, Devang, is it clear?
Yes.
Okay. Next. Question number 7. If all these are clear to you people, try out number 7 and quickly solve. We have to move on to the next topic.
Sir, can you show the question?
Huh?
So can you show the question?
Yes, I'm posting. I'm posting. And give the answer in terms of expression only. No need to simplify. Samita, did you understand the previous one?
Yes, sir.
Okay, try number 7, everyone. Solve. Should I start, everyone?
Sir, send it.
Send quickly. Similar type of problem. Okay, so everyone I'm solving. Nandini, Samita, Anandit, and Devansh. How many sides are there? How many sides are there? Hello. Anandit, tell me.
Send it.
So 6.
6 sides are there on a queen decagon. 15, right?
Oh, sorry.
Yes. Nandini, your answer is correct. So we need to find out the number of sides of the hexagon. No, I mean, we need to find out the number of hexagons that can be formed if none of the sides of the hexagon is also a side of the queen decagon. So in what case the side of the queen decagon will also be the side of the hexagon? Tell me, in what case?
When the vertices selected are consecutive.
Exactly. When you select these two vertices, right, Samita? Are you getting?
Oh,
Yes.
If
smart.
we select these two vertices, consecutive vertices, right? Tell me, Devan and Anandit.
Yes, sir.
So that means we need to select the vertices from the gaps. Okay. So tell me, number of gaps in linear will be how much? Tell me. In a linear arrangement, after removing 6 vertices, how many gaps will be there? Number of gaps in linear? In linear arrangement, how many gaps will be there? Huh?
10.
10. Out of the 10 gaps, we need to select how many gaps? Tell me, Anandit. We need to select 6 gaps. So 10C6. From here, we need to subtract those cases when we are selecting the first and the last gap. Minus 2C2 into 8C4. Right, tell me, Anandit, Devansh, Samita, are you getting? Tell me. Anandit and Devansh, is it clear?
Yes, sir.
Okay. Total number of selections. Our next topic is total number of selections. Okay. So there are many types. Okay, type 1. What is the total ways to select? Pay attention. Selection of at least one out of n distinct things. Selection of at least one out of n distinct things. What does it mean? Means number 1, either you select one object. So tell me, in how many ways can you select one object out of n things?
N.
NC1, number 2. Or you select 2 objects. In how many ways this can be done? NC2.
NC2.
Okay, dot, 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 dot. Or you select n objects. This can be done in NCN ways. So what is the total number of selections? Therefore, total number of selections will be equal to NC1 plus NC2 plus NC3 plus up to NCN. You people know the summation of this particular series? Tell me. NC1 plus NC2 plus NC3 plus up to NCN. You people know the summation? This will be 2 to the power n minus 1. Actually, sum of all binomial coefficients. Okay, these are all binomial coefficients except NC0. Anyone has done binomial theorem in school or anywhere?
Yes, sir. Schooling we have done.
Yes. So might have done that sum of all the binomial coefficients is equal to 2 to the power n. Right.
Yes, sir.
Okay. So over here NC0 is not present. So that's why I subtracted 1. Is it clear?
Yes.
Raktim, Onini, Deva, Anandit, is it clear? Shamita, is it clear? Hello. Therefore, total number of selections. Total number of selections. Therefore, the total number of selections of at least one out of n distinct things. Of at least one out of n distinct things. Will be equal to 2 to the power n minus 1. Okay, next. Samita, you understood type 1?
Yes, sir.
Type 2. Type 2. Number of ways to select one or more things. Okay, or you can say number of ways to select none, one or more things. Out of n identical objects. Now all are identical now. Out of n identical objects will be how much? Okay, first of all, let us calculate, then I'll put the number. Okay. So tell me, what is the number of ways to select? Nothing. In how many ways you can select nothing? 0 things. Tell me every one way. In how many ways can you select one thing, one identical thing? Tell me, in how many ways can you select one thing?
1.
That is also one. In how many ways can you select two things?
1.
Dot, 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 dot. In how many ways can you select n things?
1.
1. So what is the total? Total ways to select none, one or more things will be none, one or more identical things
N plus 1.
will be equal to n plus 1. Okay. Next. So over here I'm writing down number of objects will be n plus 1. Okay, this is the proof. Type 3. Type 3 is very, very, very important. Okay, type 3. So number of ways total number of ways to select. Total number of ways to select when P are identical, when P objects are identical, alike of one kind, Q objects are alike of another kind, and R objects alike of another kind. With at least one selection. Means at least one object you have to select. One selection will be equal to P plus 1 into Q plus 1 into R plus 1 minus 1. Okay, this is very important. Let us see the proof. Okay, using shop method. Let us say that there are 3 shops. Let us say that there are 3 shops. Okay, in one of the shop there are only pencils. Another shop there are only pens. Another shop there are only pens. And another shop there are only erasers. Okay, in one shop there are only pencils. Another shop there are only pens. Another shop there are only erasers. Over here, let us say that there are P pencils. Over here, let us say that there are P pens. And over here, there are, let us say, P erasers. Okay. So, what is the number of ways to select? Tell me. Either you will select, okay, all are identical pencils. Try to understand. So, from case 2, what is the number of ways to select? None, one or more identical things will be n plus 1. Right, tell me everyone. When you go to the shop 1, pencils, either you will select 0 pencils, or you will select 1 pencil, or you will select 2 pencils, or you will select 3 pencils, or you will select P pencils. So total how many ways? Tell me everyone. In how many ways can you select the pencils? Tell me. Amini, Devang, Pratim, Samita, tell me.
P plus 1.
P plus 1. Right, Samita, are you getting? Tell me. Anandit, are you getting?
Yes, sir.
In how many ways will you select? Acha, over here there are Q pens and R erasers. How many ways can you select Q erasers? Tell me.
Q plus 1.
Q plus 1. In how many ways can you can select R plus 1 erasers? Right. So therefore the total number of ways to select at least one item. To select at least one item. Okay. Will be equal to total number of selections. Total number of selections minus you select nothing. Right. So what is the total number of selections? P plus 1 into Q plus 1 into R plus 1 Now you people tell me, in how many ways can you select nothing?
One way.
One way. Means you are not even visiting the shop. So
Sir, can you please
yes.
repeat the P plus one which you
Can you please?
said the P plus one which you mentioned?
Okay. When you are going to the first shop, pencil shop, okay, either you can select 0 pencils, or you can select 1 pencil, or you can select 2 pencils, or you can
Yes,
select three
now I
pencils.
understood. Now I
Okay.
understood.
Right, because all are identical pencils. Right.
Yes, sir, got it.
Type 4. So the expression for the last type, somebody will tell me. Raise your hand. Type 4. Number of ways to select. Number of ways to select at least one object. At least one object, out of which out of which P are alike of one kind, Q alike of another kind, another kind, and R are alike of another kind, R objects alike of another kind. Okay. And S objects are distinct. Can somebody raise your hand and tell me quickly? There are S objects distinct. Okay. Yes, let's see who has raised the hand. Yes, Sonali, go on.
So P plus 1 into Q plus 1 into R plus 1 into 2n minus 1 minus
Uh,
n.
what 2n minus 1 minus
So 2 to the power of n minus
n? Where is n coming from?
2 to the power of s, sorry.
2 to the power s. Now whole thing is subtracted by 1. Right?
Ah, yes, sir.
Yes. Tell me, is it clear to everyone? Since it is actually a combination of type 1 and type 3. Right. Type 1 was selection of at least one out of n distinct things. Okay. That is 2 to the power n minus 1. And type 3 is selection of at least one, when P are alike of one kind, Q alike of another, R alike of another. Tell me, Samita, did you understand?
Yes, sir.
Anandit, Devang, did you people understand?
Yes, sir.
Devang?
Yes, sir.
Okay. I'm posting another question. Solve. Only your answer is correct. Okay, should I start everyone? Number 8? 8 part 1?
Please wait. I'm solving the second part. I'm sending them all together.
Okay, send quickly.
Sir, only the expression, right?
Like first one is a simple answer. You can simplify.
Yes, first
Second
one is
one is
simple. Second one is a bit
all
big.
only the expression is enough.
Okay, sir.
Yes, Anandit, 8 part 1 is correct. Samita, 8 part 1 is correct. Part 2 is correct. Devang, 8 part 1 and 2 both are correct. Only 8 part 1 and 2 are correct. I'm checking 9. 9 part 1 is correct. Who is left? Raktim, should I start? 8 part 1.
Just send me.
Send quickly. Yes, only part 2 is also correct. Very simple, very easy. Raktim, check 8 part 1, part 2 also. So Raktim, I'm starting 8 part 1. Pay attention. There are 3 different maths books. There are 4 different physics books. There are 5 different chemistry books. How many different selections can be made? So that the selection consists exactly one book on each subject. Exactly one book on each subject means what? In how many ways can you select one math book? There's only one way to select one maths book. Are they alike maths book?
Three.
3C1, right? In how many ways can you select one physics book? So 3C1 into 4C1 into 5C1, right? Done. This is your answer. Start telling me part 2. At least one book on each subject. So in how many ways can you select at least one maths book? Tell me. Think there are 3 different maths books. In how many ways can you select at least one maths book? 4. All are distinct now. Which type we have to use? Tell me. Type 1, type 2, type 3, type 4. Tell me. Think. So Shomita, your answer is correct. Which type we have to use? Type 1, type 2, type 3, type 4. Which one? Type 1, na? So it will be 2 to the power 3 minus 1. Right, tell me. One physics book, 2 to the power 4 minus 1. 4 to the power 5 minus 1. Is it clear? Go and solve number 9. Okay. Those who have solved number 9 also, I'll post number 10. Yes. Anandit, 8 part 2 is correct. You people solve 9. Yes, those who have solved number 9, you people can move on to 10 also. 10, I'm showing 2 subparts currently. Okay. I mean, 4 subparts I'm showing. You people send. Yes, Devang, number 9 is correct. Who is left for number 9? I think Anandit, Raktim. 9 is. Raktim, you have sent me the answer of 9. Which part? Tell me the part number.
Is part 1 and Indian maths for part 2.
Uh, Wait a minute. Actually, over here you have to consider fruits of same species are alike. Okay. Understood, Raktim?
Yes.
You have to consider fruits of same species are alike.
Yes, sir. Yes, continue.
Okay. Anandit, 9 part 1 is correct. 9 part 2 is correct. Okay, Raktim, should I start? 9?
So 1, sir.
Okay. Quickly send me these 10 4 parts also.
So what do you mean by proper devices?
Means all the devices except the number and one itself. I mean, one and the number itself. Okay. Okay, Onini, part one is correct. Yes, Vaktim, should I start 9?
Yes, yes.
Over here, they are asking us at least one fruit of every species. Okay. In how many ways can you select at least one grapes?
So one.
Why one? Either you select one grape or you select two grapes. So two. In how many ways can you select?
So three.
Three.
Into
So
three.
two. Is it clear?
Yes, I got it.
And similarly, tell me the next one. Part two. What is the number of ways?
So p plus one into p plus one minus.
Correct. That gives us how much? 59.
Yes.
Okay. Short number 10. Yes, Shomita. Shomita, check 10 part 2. Others are correct.
Okay, sir.
Only all your answers are correct.
Sir, can you please once again tell that number of proper devices? Proper devices means the what does it mean?
Means all the devices except one and the number itself.
Hello. Okay, sir.
Devank, what are you doing? Check part 2. What have you done? See, others are correct.
But sir, one and the number itself, so we have to
That
divide
is
by
that
this,
is
right?
okay. Calculation, you see, calculation.
Yes, yes, yes.
It's a criminal offense. What you did. Yes, Anandit. 10, 1 to 4 is done.
No, sir. I'm giving the answer right now.
Send quickly. Keep sending your answers. Anandit, check part 2. Part 1 is correct. Yes, Anandit, part 3 is correct. Part 4 is also correct. Raktimar is sending. Okay, those who have solved 1 to 4, you people can start 5 to 8 also. Keep sending. Yes, Soumita, 5, 6, 7 are correct. Yes, Anandit, 14.5 is correct. I mean, part 5 is correct. But Anandit, you have to check part 2.
Sir, is part 2 now correct?
Now correct. Solve part 8.
Yes, sir.
Okay, Raktim, I'm starting, okay? Raktim, tell part. Send, at least send 1 to 4 first. How many? Part 5 is correct, part 6 is correct, part 7 is correct. Raktim, no, you are making a mistake, Raktim. Raktim, pay attention. Number of devices. Okay. So first of all, what you do is you factorize 75600. So Raktim, did you factorize? What is the factorization I want to know?
So I'm getting 2 to the power 4 into 3 to the power 3 into 5 square into 7.
Okay. Now consider that there are 4 shops. Okay.
Sir, I was doing like 4 plus 1 into 3 plus 1 into 2 plus 1 into 3 to the power 1.
Into 1 plus 1. But why are you subtracting 1? Even if you select nothing, that is also a divisor of 75,600, na? Right?
Yes, sir, now I understand.
Number of devices will be equal to 4 plus 1 into 3 plus 1 into 2 plus 1 into 1 plus 1. That will give us 720. Oh, sorry, 120. So I'm going to generalize this, everyone. Generalization. Okay. Generalization. If n equal to p1 to the power alpha 1 into p2 to the power alpha 2 into p3 to the power alpha 3 into dot 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 into pk to the power alpha k, where p1 p2 up to pk are distinct primes. P1 p2 pk are distinct primes. Okay, then number of devices of n. Number of devices of n will be equal to alpha 1 plus 1 into alpha 2 plus 1 into alpha 3 plus 1 into dot 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 up to alpha k plus 1. Okay, the generalization.
So can you show the generalization once again?
Okay. Yes, Anandit 6 and 7 are also correct. Raktin part 2 is correct.
Thank you, sir.
Yes. Part 2 will be 118. Number of proper devices. Okay. Keep on solving, everyone. Devang, solve 5 to 7 also, 5 to 8. Okay, Raktin, I'm solving 10 part 3. Number of odd devices. So over here, how will you get an odd divisor? Tell me. Raktin? By not going to shop 1. Right.
That is not divisor of 2.
Yes. Number of odd devices will be equal to?
Just exclude the 2 and take the other thing.
Exactly. 3 plus 1 into 2 plus 1 into 1 plus 1. That gives us how much? 24. So what is the number of even devices?
So we have to consider at least 1, 2. Then we have to select the other thing.
Or we can subtract from the total. Right. Which one is better?
The second one.
Is it clear?
Yes.
Next. Solve 5, 6, 7, 8. Okay. So I'm solving this one 5. Number of devices of the multiple of 5. Okay. That means you need to select at least one 5. Right. Tell me. You need to select at least one 5. So at first only you select one 5. Within brackets you'll get 2 to the power 4 into 3 cube into 5 into 7. At first only you select one 5. So what is the number of divisors which are multiple of 5? Which are multiple of 5? Tell me. Equal to 4 plus 1 into 3 plus 1 into 1 plus 1 into 1 plus 1. This gives us how much? 80. Is it clear? Raktim, Anandit, are you getting?
Yes, sir.
Okay. We solve 6. Number 6 says number of devices of multiples of 10. Quickly. Solve 6 and 7 quickly. Okay. Only part 8 is done.
No, sir.
Okay, I'll solve it. Part 8.
Sir, I got it. I just need to write it.
Okay. You can send only the expression, no problem. Yes, Raktim, part 6 is correct. Yes, only right answer. Okay. So only since you have done part 8, solve part 9 and 10 also. Can you see part 9 and 10?
Sir, I can't read the first line. Yeah, now it's fine.
You can read it now?
Yes.
Okay. Okay. So Raktim, part 7 is done.
This is send.
Send quickly.
Just send it.
Oh, send. It's correct. Devang, part 6 and 7. What happened?
So trying to solve.
Pay attention. So just like I've solved part 5, part 6 also let us solve. In part 6, we need to find out those devices which are multiples of 10. So that means you select 1, 2, and 1, 5 in the beginning only. Right. In the beginning only, you select 1, 2, and 1, 5. Are you getting? Tell me.
Yes, sir.
So this implies n equal to selecting 1, 2, selecting 1, 5. Within brackets, you are getting 2 cube into 3 cube into 5 into 7. So what is the number of ways? Number of ways, now you just select all the
Yes,
devices.
64.
How much?
64.
64. Similarly, Devang, think about the next one. Number of devices of the multiples of 12. Quickly. Yes, Anandit, part 8 is correct. Only part 9 is correct. Is Devant right answer? Okay, part 8 I'm solving. Okay, so Shomita, Raktim, and Devant, pay attention, part 8. You need to find out sum of all the devices. So pay attention. Okay, so if n equal to 2 to the power 4 into 3 cube into 5 square into 7. Okay, what is the sum of all the devices? What is the sum of all the devices? In shop number 2, it will be 2 to the power 0 or 2 to the power 1, 2 cube, sorry, 2 square, 2 cube, and 2 to the power 4 multiplied by 3 to the power 0 plus 3 to the power 1 plus 3 square plus 3 cube into 5 to the power 0 plus 5 to the power 1 plus 5 to the power 2. Then 7 to the power 0 plus 7 to the power 1 plus 7 to the power, oh, only 7 to the power 1. So this will be the total sum. Right, Shomita, are you
So
getting?
is it 4 plus 1 into 3 plus 1 like that?
No, after this you have to simplify.
Yes, sir.
Okay,
Oh,
because you see, you multiply any two of them, any three of them, okay, you will always get a divisor of n. Are you
yes,
getting?
yes, sir.
Tell me, Raktim, Anandit, is it clear?
Yes, sir.
This will become how much? They are in GP, so it will be 2 to the power 5 minus 1 upon 2 minus 1 multiplied by 3 to the power 4 minus 1 upon 3 minus 1. Anandit, Devant, is it clear?
Yes, sir.
And multiplied by 7 to the power 2 minus 1 upon 7 minus 1. Okay.
Sir, is part 9 and 10 correct?
I'm checking. Only check number 10. Yes, 9 and 10 are correct. Okay. So after this, you simplify. I'm telling you the simplification. It will be 307, 520, I guess. 307, 520. Let me see. 520. Okay, so I'm going to generalize this. Okay, everyone. Note, if n equal to p1 to the power alpha 1 into p2 to the power alpha 2 into p3 to the power alpha 3 dot into pk to the power alpha k, where p1, p2 up to pk are distinct primes, then sum of all the divisors. Sum of all the divisors will be equal to P1 to the power alpha 1 plus 1 minus 1 upon P1 minus 1 multiplied by P2 to the power alpha 2 plus 1 minus 1 upon P2 minus 1 dot Pk to the power alpha k plus 1. Are you getting, everyone? Tell me. If you're not getting, let me know. Minus 1 upon Pk minus 1. Okay. Next. Is it clear, Samita? Generalization, you have understood? Okay. So we solve part 9. Number of ways in which n can be resolved into as a product of two numbers. So pay attention, everyone. Anandit, Devang, Raktim, pay attention. Part 9. See, n is equal to 75,600. It can be written as 1 into 75,600. Right, tell me. Raktim?
Yes,
It can also be written as 2 into 37800. It can also be written as 3 into 25200. It can also be written as 4 into 1, 2, sorry, 18900. Okay, I'll write down all the ways. I'll write down all the ways in which 75,600 can be written as a product of two numbers. Dot. Somewhere in between you will get 4 into, I mean, in the end, somewhere in the end, you will get 4 into, sorry, 18900 into 4. Okay, are you people getting what I am doing? Left hand side I am increasing, right hand side I am decreasing. Then 25200 into 3. Okay. Then 37800 into 2. And lastly 75,600 into 1. So what do you think? Devang, Raktim, Anandit, how many times I have written? Can you tell me? What do you think? How many times I have written? Tell me. I have written the total number of times in which 75,600 can be resolved into two numbers.
120.
120 times. Right. Devang, Anandit, I have written 120 times.
Yes, sir.
Okay, because these are all factors of 75,600. But the first way of writing and the last way of writing is same. Right. First way of writing and the last way of writing is same. Second way of writing, second last way of writing is same. So I have to divide it by 2. Therefore, the total number of ways will be equal to 120 divided by 2, which is 16. Is it clear to everyone?
Yes, sir.
Okay, I'm solving the last one. Number of ways in which n can be resolved as a product of two numbers
Sir,
which are
sir,
relatively prime. Yes, on any your answer is correct. Number of ways in which n can be resolved as a product of two numbers, product of two devices which are relatively prime, means they should be prime to each other. What is the meaning of relatively prime? Tell me. Are these two numbers relatively prime? Tell me.
yes, sir.
Raktim, what do you think? Are these two numbers relatively prime?
Yes, sir.
Why?
Sir, because they
What?
are not divisible by any common number
Exactly.
except one.
Other than one. Yes. Devang, are you getting?
Yes, sir.
Okay. Now, in how many ways we can write? I'm telling you. 2 to the power 4, 3 cube. Okay. 5 square, 7 to the power 1. One of the way to write. One of the way to write 75,600 as the product of two numbers will be 2 to the power 4 into 5 square into 3 cube into 7. This is one way to write. Right, tell me, Raktim, Anandit and Devang. Yes or no?
Yes, sir.
Yes, sir.
Anandit, are you getting?
Yes, sir.
Okay. Is will this work? Is this valid? Tell me. Is this valid? Tell me.
No,
This is not valid. This is valid. Another way to write is 2 to the power 4 into 3 cube into 5 square into 7. This is also valid, right?
yes,
Tell
sir.
me. Okay. Basically, if you are selecting a shop, if you are going to a shop, you have to select all the items. Right? Tell me. If you are going to a shop, you have to select all the items. So what I'm going to do is, and it can happen that you are selecting two of the shops at once, one of the shop at once, or none of the shops at once. Okay, it can happen. So over here, what do we need to do is, over here, we need to make we need to make two groups. Make two groups from these four shops. Right. Now, one of the way to make groups will be case one. One of the way is group of 0 and 4. Right. In how many ways? Tell me, what is the total number of ways to form two groups? One of 4 and one of 0. Tell me, what is the number of groups? You have done group, yes or no? You have done number of ways to form groups. Tell me, in how many ways can you form group of 4 and 0 out of 4? Tell me. Devang, Kanandit, Raktim, tell me.
One way.
Tell me, Raktim, how many? In how many ways?
One.
Are you asking me or telling me?
So I didn't understand the question.
Okay, okay. So tell me, basically, we need to write 75,600 as a product of two numbers which are co-prime to each other. Okay, Raktim.
Sir, that part I understood. The case one, sir.
Case one, see, did you understand that you have to make two groups out of four shops?
Yes, sir, that I understood.
So, one way of making groups is group of 0 and 4.
Yes, sir.
Right, 4 can be written as 4 plus 0. So, in how many ways can you form a group containing 4 elements and another group containing 0 elements? Tell me.
So one.
One way only,
Yes, sir.
right? Devang and Anandit are you getting? That is 4C0. Right, Devang and Anandit, what happened? Are you people getting?
Yes, sir.
Okay. Another way is group of 1 and 3. Tell me. In how many ways can we form a group of 1 and 3 out of 4 shops? Tell me. What is the number of ways to form a group of 1 and 3?
Four.
4C1? Okay, case 3. In how many ways we can form a group of 2 and 2?
4C2.
4C2. Are you sure 4C2? Tell me. Anandit, what he said is correct. 4C2, that is 4 factorial by 2 factorial into 2 factorial. What he said is correct. Tell me. Devang?
Yes, sir.
And Anandit, what do you think?
I
What
also
do you?
think yes.
Okay. You have gone through the video properly, right? Where I have explained groups.
Yes, sir.
Okay, tell me. Samita, what do you think? Whatever they have said, number of ways to form two groups out of 4 people in which
Sir, into 1 by 2 factorial.
Yes, sir. I also think.
of strength 2 and 2. Right. So what previous answer like 4C2 was correct? Tell me.
Sir, will it be 4C2 into 1 by 2 factorial?
Into 1 by 2 factorial, no? Right. Tell me. Raktim, I mean, Anandit and Devang, are you people getting? We have to multiply by 1 by 2 factorial. Right.
Yes, sir.
Anandit,
Yes, sir. Yes, sir.
you have forgotten.
Yes, sir. I forgot about that.
Therefore, total number of ways will be equal to 4C0 plus 4C1 plus 4C2 by 2 factorial. Now, what I'm going to do is I'm going to take 1 by 2 common. Within brackets, you are getting 2 into 4C0 plus 2 into 4C1 plus 4C2. Actually, this 2 into 4C0, can I break it as 4C0 plus 4C4? Tell me. And 2 into 4C1, I can break it as 4C1 plus 4C3. Okay, what is this, everyone? What is this? 4C0 plus 4C1 plus 4C2 plus 4C3 plus 4C4. What is this? Tell me. Anandit, Raktim, Devank, you should be able to identify this. You only told me today. Huh?
2 to the power 4.
2 to the power 4, right?
Yes,
Sum
sir.
of all binomial coefficients. 2 to the power 4. This will give us 2 cubed. Or you can say 2 to the power 4 minus 1. Because there are in total 4 shops. So thus we can conclude. Okay, note it down. I can generalize this. Thus we can conclude that the number of ways n can be written as a product of two numbers which are relatively prime to each other, will be equal to 2 to the power n minus 1 when where n is the number of distinct primes. N is the number of distinct primes in factorization of n. Okay. Tell me, is it clear to everyone? Tell me, Anandit, Ratin, Devang, is it clear?
Yes, sir. Yes, sir.
Amini, have you understood? Shomita, is it clear?
Yes, sir.
Yes, sir.
Okay. 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 Achha, so everyone, tomorrow everyone is attending the class, right? Tell me.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Devang, you are attending, right?
Yes, sir.
So tomorrow, can we start from 8:30 to 11:30? Tell me. Everyone? Nobody has a
Yes, sir.
problem?
No,
8:30?
sir.
No,
Yes.
sir.
No, sir.
Shomita? Okay. So tomorrow's class will be from 8:30 p.m. Okay. It will end at 11:30 or so. Okay. Okay, so everyone, I think we can keep it till now. Next class tomorrow again will continue. Thank you everyone and good night.
Thank you, sir.
Thank you, sir.
Yes.
Thank you.